Now we come on to the next group of use cases, commercial use cases, which are just illustrative. They only cover a few of the very many important possibilities here. The first one we have is a rather general discussion of cloud computing for the financial industries, which is banking, security and investment, insurance. And obviously, that says here the discussion is only within the US, but of course, it could be um, the ideas are basically global. And the suggestion is that big data technologies can be extended into the financial industries to advantage. And examples of important analytics, which actually use MapReduce, which is Hadoop an example of, fraud detection, risk analysis, and also for overall what you might call knowledge management and providing rich sources of information for customers and, of course, your in-house uh, security analysts. Um, a lot of this data is currently done by relational database management systems, Oracle, MySQL, etc., because this is a relatively old application, and so some good applications were already developed on the older technologies. And also, there are many aspects of banking, like uh, processing your credit card application, for which relational database management systems are perfect. For individual so-called transaction processing, OLTP, online transaction processing, I don't think big data has got necessarily any better solution than the older technologies, which are highly optimized for that particular example. In fact, the reason why big data and the newer technology are becoming important is because traditional databases were tended to have a huge emphasis on transaction processing with relatively simple atomic transactions, whereas today's big data applications tend to, even if they have streaming transactions, tend to be much more complicated transformations and filtering is needed on the data. And much more complicated ways of integrating the data together are needed, for which the traditional databases can be used, but are not clearly the most effective solution. So this has this streaming characteristic, which I already mentioned actually earlier in the government use case section. Um, and we know that a lot of, in fact, possibly most banking data comes in a streaming fashion. The stock market keeps ticking away, and obviously has transactions that come every second, and perhaps even faster than that if you really want to have your analytic engine poised to take advantage of small market imbalances. So streaming is a very important example here. And that we will see that in a lot of other cases with sensors, with just people actually coming in from the web. All of those type of applications tend to be streaming because they have a sort of big repository of data and they have other related data coming in, adding to the original data. And this is very important. It requires special processing. And if you're doing, say, recording things in clusters, um, you have to run a pretty sophisticated algorithm to find your initial clusters, and it uses a large data set. However, once you have those clusters and along comes a new point, you can take that point and see which cluster it belongs to without redoing the cluster analysis. So there are aspects of streaming processing which are special and should be done specially. Here we have an interesting contribution from Mendeley. Many of you may know Mendeley. It's a startup which is basically doing citation management and analysis. And as you see, it has a big database, currently 15 terabytes, but growing rapidly. And that has all the types of things we want to cite, which for scientists are research documents. And they have technologies to allow one to group these things together, to create shared bibliographies, and use the activity recorded on Mendeley to actually find out real results on what's important scientifically. There are actually many such, there's ResearchGate and academia.edu, which are also similar types of companies. So they use text mining and classification systems, which automatically recommend what research might be useful to you. Because when you have all the world's data and you see what somebody is currently researching, you can suggest other things. That's the same idea that Amazon uses with books and other things. When it sees what you've read and what then looks at this database to see what people who read similar things that you have also read, they suggest that to you. So that's the so-called recommender engine, a key technology we'll cover later in this course. So they note that Mendeley is actually supported on a commercial cloud, Amazon Web Services, and they're using they use Python as a language, but the other aspects are technologies from the Apache Big Data Stack. And they have their own, they don't explicitly say which machine learning library they use. They use latent Dirichlet allocation, which we will not cover particularly in this course, but it's an important technique for analyzing documents and dividing those documents into groups based on so-called latent or hidden factors, and this gives you a way of generating topics and things like that. And as they point out that they're currently doing everything in batch with MapReduce Hadoop. They have 400 million documents, and they have about 700K new uploads every day. So managing all of this is complicated, and that's what they're using all these technologies to do. And I expect this type of application to grow in importance. I think the traditional approach to managing documents, which is rather isolated, this clearly throws away an enormous amount of information. For instance, I edit a journal. I believe these technologies could make my editing of journals so much easier because I should be able to go to a properly curated set of data like that in Mendeley and find out all the best reviewers for a new submitted article, because the Mendeley can take one article and find out all the closely related articles. So we introduce here for the first time some very important new computational types. MapReduce itself, we did MapReduce Stat. The general MapReduce has more complex reduction functionality, and it is the most important big data processing paradigm. We will cover MapReduce later on. Iterative MapReduce is something which is of growing importance because it's when you want to look at certain applications involving iteration. Collaborative filtering is not really iterative, but clustering is. And latent Dirichlet allocation is iterative. And then an iterative MapReduce, which stores information, caches information in memory, is an appropriate approach. Classification is a very broad term, and so many of these big data problems want to take their data and divide it into categories. And finally, under parallelization, we have item parallelization. And here the items are basically documents, the things that are being cited. And we will find later on some related examples, tweets, blogs, documents, and web pages. And one looks at the so-called bag of words model typically, and looks at the character and words in these documents, web pages, tweets, and blogs. And as those characters and words effectively characterize a document, you look and see what types of words it had in it, how often they occur, and compare that with other documents. That allows you to effectively match documents. So this is a powerful technique that we will discuss later on in the class.